You count things every single day, right? But have you ever stopped and wondered why we do it the way we do? Well, today we're going to pull back the curtain on something called number bases. This is the secret language that, believe it or not, creates a huge difference between how you think and how a computer thinks. So let's dive in and see how this all clicks together. Seriously, have you ever really, truly thought about it? Why the number 10? I mean, our whole world revolves around counting in tens. It feels so normal, so baked in. But the real reason we do it is actually super simple. And it's about as human as it gets. Okay, get this. The answer has literally been right at your fingertips this whole time. Yep, we've got 10 fingers. And for thousands of years, they were our very first calculators. That system, the one built on our 10 fingers, is what we call base 10. Alright, so that's us. But what if you are building something that doesn't have fingers? What happens when your world isn't based on biology, but on pure electricity? Well, that's when you have to think way beyond our 10 little digits. So, let's break it down. At its heart, a number base is just the size of your counting toolkit. Think of it like a set of building blocks. It's the number of unique symbols you have to play with before you have to start stacking them up to make bigger numbers. And in our everyday world, our decimal world, that toolkit is 10 digits strong, right? You know them, 0 all the way up to 9. And it's kind of amazing when you think about it. With just those 10 little symbols, we can build any number we could possibly imagine. Okay, so now we get what a number base is. Let's look at the two big ones, the ones that really matter. This is where we're going to build a bridge from our world right into the world inside the computer. It's like a tale of two completely different languages. And here it is, the big difference side by side. On one hand, you've got our system, base 10, and on the other, you have base 2, also known as binary. Look at that tiny little toolkit. It's just a 0 and a 1. That's it. And that incredibly simple two-digit system, it's the native language of every single digital device you've ever used. Which brings up a pretty good question, doesn't it? Why would something as powerful and complex as a computer use a language that seems, well, so basic? Just two digits? The answer isn't in the software. It's actually in the hardware itself. See, a computer's brain is really just made up of billions and billions of microscopic little switches called transistors. And each one of those switches can only be in one of two states. It's either on or it's off. And that is a perfect physical match for binary, right? On is 1, off is 0. It's the simplest, most elegant way you could possibly turn raw electricity into actual logic. Okay, so that's the big puzzle, isn't it? If all you have are ones and zeros, how in the world do you do math? I mean, how do you even write the number 2? Let's actually walk through it together. In our world, 1 plus 1 equals 2. Easy. But remember, in the binary world, the digit 2 just doesn't exist. So what do? Well, think about what happens in our system when you add 9 plus 1, you run out of single digits, right? So you put down a 0 and you carry the 1 to the next column to make 10. Binary does the exact same thing. When you add 1 plus 1, you run out of digits. So you put down a 0 and carry the 1. The result is 1, 0. And that, my friends, is how a computer writes the number 2. Right about now, you might be thinking, okay, that's kind of cool, but is this just some nerdy thing for computer scientists? And the answer is absolutely not. This core idea is literally woven into the fabric of our everyday lives. You just might not see it. I mean, it's everything from the raw binary code that makes your computer work to how your Wi-Fi password gets scrambled and sent through the air. Even something as simple as your phone number. That's just a base 10 system designed to give every single phone a unique ID. All these systems are really about one thing, using a limited set of digits to organize a huge amount of information. And you know, that's the real takeaway. It doesn't matter if you're a student or you're just curious, getting a handle on these fundamentals is like getting to peek under the hood of the technology that basically runs our entire world. It's what takes you from being someone who just uses technology to someone who actually understands it. And for anyone out there who wants to go deeper, the path really does start in the classroom. I mean, textbooks all over the world are packed with exercises on this stuff. And it just goes to show you there's a straight line from what might seem like a basic math problem to the complex logic that powers everything we do online. So, if you remember one thing, remember this. It all started with us counting on our fingers. Then that simple idea evolved into the language that powers our entire digital universe. It's a straight shot from a simple lesson in a classroom to the code that runs the entire internet. And I'll leave you with one final, kind of wild thought. Our way of counting is tied directly to our biology, right? Our 10 fingers. A computer's counting is tied to its physical hardware, on and off switches. So here's the question. If humans, say, evolved to have 12 fingers, would we eventually force our computers to learn to count in base 12 too?